Good morning everyone. So today we'll be learning about integration using partial fractions. Now I'm not sure if all of you have seen this code, but it's there in the first page of your NCERT textbooks, the class 12, the integral chapter. So it's what it says is, just as a mountaineer climbs a mountain because it's there, so a good mathematics student studies new material because it is there. Now I don't entirely agree with this quote, because if you're actually interested in mathematics, you do questions for the fun of it. But sure, for a chapter like integration, I guess it works, because the more you practice, the more you get. So let me jump to the learning target for today. So I'll be telling you how to use partial fractions, when to use partial fractions, but more importantly, I'll be telling you how to easily use partial fractions, how to save time while doing so. Because I'm sure all of you have at least studied partial fractions once. Yeah? Okay. So I'll just quickly go through the steps. Okay. So for using partial fractions, there are a few conditions. So first you have to check if the function is a rational function. So rational functions are functions which are division of polynomials. And what are polynomials? They are expressions with whole number degrees. And the QFX here should not be 0. That's it. And then the second condition is that the degree of the numerator should be less, I think it's a mistake there, less than or equal to the degree of the denominator. And if it is equal to or greater, then you have to perform polynomial division. The third condition is very important. Okay, so the denominator should be expressed as factors of linear expressions or maybe irreducible quadratic terms. But let's say you get a cubic expression in the denominator, then it's probably a sign that you shouldn't use partial fractions and you should be using some easier ways of integration like substitution. So the direct derivative of the denominator might be there in the numerator. So watch out for that. Now this is also given in your textbook. This is the rules for using partial fractions. I'm sure all of you know it. So I'll move on to the next one quickly. So here the denominator is linear, so you split it. Here it's a very interesting thing. You have a square of a linear expression. So why not just directly write the square? Why are we including this linear term here? Does anyone know? No one? You want me to explain? I can explain right now. Okay. So let's say we have a question like, I'll take a question. Let's take this question. Can someone read it out? Yeah? Okay. Now what I'm saying is, why not just write this as a by x plus 1 plus bx plus c by x plus 2 the whole square, which is what you would probably think of if you're studying partial fractions for the first time. Now what I'm saying is, this c, right, can anyone manipulate the c and make it so that we get it in this form? We get it in this form. Can anyone do it? Manipulate that c into other constants so that we get x plus 2 in the denominator, just x plus 2 without the square. Yeah?
It's a by x plus 1 plus b by x plus 2 plus c by x plus 2.
Yeah, so how can we get it from here?
You can take one x plus 2 in one constant and then the other x plus 2 square in another one.
Okay, I don't think you're understanding the question. It's fine, I'll explain. So this c, let's say, okay, this c, bx plus 2b, okay. This c you can write as some constant 2b plus, let's say, not b, sorry, some constant 2c plus d. Sorry, b only, my bad. 2b plus d, okay. Now bx plus c is what? 2b plus d by x plus 2 the whole square, right? Okay. Now what I'm doing is I'm splitting this d, this part separate and this part separate. So I'll just write it here. X plus 2 the whole square plus d by x plus 2 the whole square. Now what happens here? You take b common, what do you get in the numerator? X plus 2. So that one x plus 2 cancels with one of the x plus 2 in the denominator, and then what do you get? You get b by x plus 2. Now that explains why you get a linear term when you are using partial fractions and not directly this. Okay, I hope that's clear. If you have doubts, I can take it again in the last 5 minutes. Okay. Now this much you probably already know. The point of my lecture here is not to teach you all this. Okay, so let's just move on. Let's just move on to the trick. Yeah. Okay. So what I did just now is expand it like this, right? So now what do you do to find A, B and C? What would you do? Anyone? Cross multiply and then? Okay. Sure. How about substituting a value for x and then finding A, B and C? That also works, right? But all those are rookie methods, I'll tell. What if I could find A and C directly? Let's say we have a linear term in the denominator raised to any power. Here, x plus 1, x plus 2 to the whole square. And it should also be noted that the denominator should be there in the denominator of the real expression which we are integrating. So x plus 1 directly there, x plus 2 to the whole square directly there, x plus 2 is not directly there. So we can't find, that's why I didn't mark it as red. So what if I tell you that A and C can be found out directly? So let's A, right? So x plus 1, what is the root of x plus 1? The 0 of x plus 1, minus 1, right? Because if you substitute minus 1 into as x, you get 0. So what you have to do is cover up x plus 1 in the original question and then substitute minus 1 in the rest of the question. So what do you get? So can someone do it for me? 2 into minus 1 plus 2. Yeah? Minus 1 by 1. So you get A as what? Minus 1. A, direct. Minus 1. X plus 2 to the whole square. What's the root? Minus 2. Cover up this whole thing. Substitute minus 2 here. What do you get? Minus 3 by minus 1. So 3 will be C, direct. So that is my trick here. You know, let me give you, and it works for everything where it is a linear expression raised to some power. So this problem, something like this is also there in our NCERT textbook. Let me take it on the board. So I'm sure you all have studied substitution, right? So you substitute some term as t and then you derivate it and then you get something in the numerator. You know, it's easy. But here I'm telling you, you take x square as t without substituting. We're just substituting in our mind, okay? We're not substituting as t and then derivating and then using that in the numerator. Just substitute x square as t. What do you get? T plus 1 by t plus 2 into t plus 3. Now I'm going to directly write a, okay? So what will be? A by t plus 2 plus b by t plus 3. T plus 2 root minus 2. Substitute minus 2 in the rest of it. What do you get? Minus 2 plus 1 minus 1. Minus 2 plus 3 1. So minus 1. Plus b. What is the root? Minus 3. Substitute minus 3 in the rest. Minus 3 plus 1 minus 2. Minus 3 plus 2 minus 1. So 2. 2, right? Okay. 2 by t plus 3. Now we are not actually substituting t, right? So you have to put t back as x square here. Now I'm sure all of you know 1 by x square plus a square. What's the integral of 1 by x square plus a square? Tan inverse. Tan inverse, right? So you can integrate directly. But another interesting intuitive method is that you can take x square outside and then what are you left with? 1 by x square plus 2 into 1 by x square into 1 by x square plus 3. Now if you check x square plus 3 minus x square plus 2, how much is that? X square plus 3 minus x square plus 2. X square cancels out. 3 minus 2, 1. So what can you write the numerator as? X square plus 1 into x square plus 3 minus x square plus 2. X square plus 3 and x square plus 3 cancels out. You're left with 1 by x square plus 2. X square plus 2 and x square plus 2 and x square plus 2 cancels out. You're left with 1 by x square plus 3. So what do you get? X square plus 1 into 1 by x square plus 2 minus 1 by x square plus 3. Now can anyone take it from here? Because this x square plus 1 you have to multiply inside anyways. So when you are multiplying this x square plus 1 inside, you write it as what? X square plus 1 can be written as x square plus 2 minus 1, right? Cancel, cancel. Same here, x square plus 3 minus 2. X square plus 3 cancelled. So in the end, integration is all about you using your brains. Okay? Use your intuition, find out the best method. I'm not saying partial fractions always. You might find an easier substitution. So use it first. So to conclude my class here today, this is from the NCERT textbook. I am sure you all have done this in your class. But I encourage you to do this using the tricks I taught you today. Okay? Cover it up, find A, you will see how fast you can go, and then you can, because in the exam as well, I asked my teacher, in the exam, they do not care if you find A using a method, they just want you to integrate. Even if you write A, B and C directly, you'll get the entire 5 marks. So I'm sure you can use this and save your time in the exam. So yeah, that's it for my presentation. If you have questions, you can ask. X raised to 4 minus 1 raised to 4, split it. Split? Yes. X square minus 1 to x square plus 1. Split this further. Yeah, sorry. Split this further. X plus 1. Now, this one. Directly you can find out using the trick. And then you will get some linear term for this. I'm pretty sure you can easily do it. Yeah, because you already have A, B and C. Yeah, otherwise you take a lot of time to actually cancel the denominator, substitute the values and then do it. So if you want me to do it, I'm sure you can all do it, right? Do you want me to do it actually? Okay. So that's it. Basically factor in the denominator as much as you can and then using integration. And it's not always log, alright? Because sometimes you might think it's log there, but then in the problem I took here, it's not log because it's tan inverse. So be careful of that. Yeah. Any more questions? See, in this question, it's not even x, it's sin x. So you can substitute sin x as t first and then derivate it, you'll get cos x in the numerator.